So, discrete event modeling. As I already said, in discrete event modeling, the whole idea is to map whatever is happening in the real world into a process, a sequence of operations that are performed over entities. Entities can be different things like clients, patients, products, packets in, let's say, a network, even ideas of projects. Really very diverse things. Operations are, let's say, delay. Entities are delayed here. Whenever you have delays and you have limited capacities, queues inevitably appear in your system. So the whole discrete event modeling is actually about delays and queues and various service policies and bottlenecks, etc. So delays, queues, resources, and also the logic of the flowcharts, like choosing the branch, etc. Are the main things, the main components of discrete event modeling. Like in this particular example, and this is something I'm going to build quickly. We have, this is a model of a bank. Clients arrive, and this is the source, the arrival block. Some people in the bank go to the ATM, which is located in there. So this is decision block, and people go to ATM. There's only one ATM. ATM usage takes certain time, and because of that, you may have a queue in front of the ATM. Delay is the model of the ATM usage and the queue. Others go to see tellers, and their potential can be more than one teller, so these are resources in our model. And this is the service block, because again, potentially may have more customers in there than tellers. A queue may appear before the tellers. So again, delay, queue, and the capacity of this, let's say, delay block is controlled by the number of tellers. Resource, delay, and queue. People who have used the ATM may also need to see the tellers, so there's this part of the flow. Otherwise, people just walk out of the bank. It's a very simple process, and we're going to build it in Anylogic. Well, optimization is again a new model. Bank. Again, we have an empty canvas, and this time I will use not the general system dynamics, I will use enterprise library. Source, this is where our clients coming into the bank are generated. Then directly after source, I think we had select output block. People decide where to go to use the ATM or to go to the tellers. The ATM is a delay block, so I will call it use ATM. And there will be a queue to ATM before the delay block. Decision is go to tellers, and people will go to tellers with, let's say with the default probability 50%. Okay, tellers. Tellers are resources, so we have a resource pool. Let's put it here. Tellers. And let's say there are 2 tellers in the bank. Service block means that entities are can only proceed through after using an available teller. So yeah, let's leave the name service. And then the last block is sync. Sync deletes entities out of the model. Sorry. We had another select output, the probability of a person who has used the ATM to go away or to join the teller queues to the tellers. So I'll call it need to see teller. Otherwise, exit. Sync, I'll rename it. Oops. Exit bank. Well, the structure is in place. All objects here have some default parameters. For example, the source will generate on average 1 customer per, what's the time unit in this model? It's minutes. So 1 customer per minute. The ATM usage time is triangular from half minutes with mode 1 to 1.5. I don't think this is realistic. I think we have, let's say, yeah, probably the minimum we can leave minimum is half minute, but the maximum usage time, let's make it 4 minutes. With the teller, same thing. Probably the shortest operation takes up 2 minutes, the typical 5 minutes, but the longest operation as long as 20 minutes. And so what is this? This is triangular probability distribution. Anylogic supports over 35 probability distributions, and so you can type here instead, for example, uniform or exponential or weighable, etc. So a lot of different distributions are supported in Anylogic. But I'll work with triangular. Okay, let's run this model. Okay, so one guy is using ATM, one is standing here in the queue. Tellers are fully utilized. And what is this? Is this a break? Huh? For the students. For the students. Okay, so our break is later, like 10 minutes. 10 minutes, that's fine. Mm-hmm. Okay, so after 181 minutes, the model signaled an error because there's queue overflow. There's 100 people in this queue, and this queue is empty. So the model is not capable of, the system is not capable of serving that that kind of rate of incoming clients. So a typical experiment with this kind of model would be to vary the number of tellers, and for that you can bring a slider here, and you can link the slider with tellers capacity from, let's say, 1 to 20. So as you can see, controls and later on we'll show animation are also part of Anylogic, and you can bring sliders and also all kind of shapes to the canvas and make them dynamic. So the capacity is 2, and the queue starts to build up. Now there are 14 tellers, and the system performs well. So it's kind of manual optimization of the system, with me using the slider to control the number of tellers and looking at the queue. Just one small bit is to one way of defining animations of your models. Let's say I want to see the tellers queue. What I'll do, I'll go to the presentation and draw a polyline. And I'll supply that polyline as the animation guide shape for the queue here. And I'll also say that my clients are animated with person picture. Entity animation shape is person. Okay. So you know that Q will inevitably grow under the okay. So that was a just a little bit of discrete event modeling with simple 2D animation in Anylogic. Question? Yeah.